Hey, welcome to the Explainer. Today, we're going to break down the essential best practices for designing web APIs. We're taking all that complex, dry documentation and turning it into a clear, practical blueprint you can actually use.
So let's start with a question. If you've ever worked with an API, I want you to think about it for a second. What's the real difference between one that was just a joy to use, totally intuitive, everything just clicked, and one that was a complete and utter nightmare?
You know what? That huge difference, it all boils down to one thing: design. Because an API, when you really think about it, is just a user interface. It's just that the users are other developers.
A great API feels clean, it feels predictable. A bad one, like that example on the left, is just confusing. Get/create order. What's that even mean? Our goal is to build the one on the right. And the principles of REST, which just stands for representational state transfer, basically a set of architectural rules for the web, they give us the exact roadmap to get there.
All right, so let's get into the nitty-gritty. The very first step, the foundation of our entire blueprint, is defining what our API is actually working with. And in the world of REST, we call these things resources.
So, what's a resource? It's really the core concept, the what of your API. It's the noun. It could be a customer, an order, a collection of products, any object or piece of data that your API needs to provide access to.
Okay, so here's the #1 rule, and this is a big one. Your resource addresses, those URIs, should always be nouns. You should never see verbs like create or get in the path itself. And why is that? It's simple, really. The action, the verb, is already taken care of by the HTTP method we're going to use.
And this is how you build that structure. It's so logical, right? You start broad with the whole collection, like all of your customers. Then you can drill down to a specific one, like customers/5. And from there, you can even get to things related to that specific customer, like customers/5/orders. It's just a clean, predictable hierarchy.
Okay, so we've got our resources named and organized. Now, what do we actually do with them? We need some tools, right? A way to interact with all this stuff.
Well, lucky for us, REST gives us this amazing universal toolbox in the form of standard HTTP verbs. Now check out this table, because this is really cool. The meaning of each verb changes depending on if you're talking to a collection or a single item. So a get to /customers fetches everybody, but a get to /customer/1, that just gets you one person. You post to the collection to create something new, but trying to post to a single existing customer, well, that doesn't make sense, which is why you see error there. It's a really smart, consistent system.
Now this next idea, idempotency, is absolutely critical for making your API reliable. It's a fancy word for a simple idea. If you send a put request to update a customer's address, you should be able to send it once or 5 times or 100 times, and the end result on the server is exactly the same. It's a huge safety net.
Okay, but what if you only want to change one little thing, like just the price of a product? With a put request, you've got to send the entire object back, even the fields that haven't changed. For big resources, that is just super inefficient.
And that is the whole reason Patch exists. It's built for these kinds of surgical, partial updates. You only send the bits you want to change or add or even remove. It makes your API way more efficient and saves a ton of bandwidth.
Building a good API isn't just about what works right now. It's about building something that can last, something that can evolve without breaking. So let's look at how we can prepare our API for the future.
Okay, HATEOAS. I know it sounds super intimidating. Hypertext is the engine of application state, but the idea behind it is actually beautiful. It's all about making your API explorable on its own. Instead of forcing a developer to read page after page of docs, the API response itself tells them what they can do next.
So what does that actually look like? Well, take a look at this. You ask for an order, and the response doesn't just give you the order data. See that links array? It's giving you the exact URIs to get more info on the customer or to update that customer. The API is literally guiding you.
Okay, but what about the scary part? What happens when you have to make a change that's going to break things for people already using your API? That's where versioning becomes your best friend. These are the 4 main ways to do it. And while they all have their trade-offs, the important thing is that you pick a strategy and stick with it. It's non-negotiable.
All right, let's get real for a minute. Let's talk about performance. Because in the real world, an API that's slow is an API nobody wants to use. We have to make them fast and efficient, especially when we're dealing with lots of data. Just picture it. You've got a database with, 100,000 orders. If you return all of them in one go, you're going to crash something. It's a disaster. That's why smart APIs use techniques like these.
Pagination lets you get data in bite-sized chunks. Filtering lets you ask for just the shipped orders. Sorting lets you organize them by price. And field selection means you only get back the 2 or 3 fields you actually care about. It's all about precision.
So after all that, what are the big takeaways? What's the blueprint we've built here? Well, it's pretty clear. You start with a solid foundation of nouns, you use the standard HTTP toolbox everyone already knows, you plan for the future with discoverability through HATEOAS and a smart versioning plan, and you always optimize for how it's going to be used in the real world.
At the end of the day, all these principles we've talked about, they're the difference between building a clean, well-lit hallway that guides developers exactly where they need to go and building a dark, confusing maze that just leaves them frustrated. So I'll leave you with this. The next time you build an API, which one is it going to be?